All right, this is part 2 of our chapter 4 review. We are just going to review the concepts in this video, starting with section 1, going all the way through section 6. So at the beginning of this chapter, we learned how to classify triangles by its sides and by its angles, and those are two separate things. Sometimes you may be asked to do both, or sometimes you may just be asked to do one or the other. There are 3 ways to classify a triangle by its sides. It's not how many sides it has, it's how do I classify the triangle by its sides. So remember, a scalene triangle will not have any sides congruent. So no sides are congruent for a scalene triangle. So a scalene triangle may look something like that, just looking at the sides. No sides are congruent. The second way you can classify it is by an isosceles triangle, and that just means 2 of the sides are congruent. So an isosceles triangle may look something like that. Now, when we talked about isosceles and equilateral triangles, we learned 2 things about isosceles triangle. The first one was called the isosceles triangle theorem. And remember that isosceles triangle theorem said if I have 2 congruent sides, which I call the legs, remember, then I have 2 congruent angles. And those angles, just as a reminder, are called your base angles. So we'll call those 2 congruent angles the base angles. And we'll label a triangle that's isosceles, but those base angles, remember, lie on the base. They lie on the base. And if I look at my isosceles triangle, there is my base. So the other thing we also learned is the converse of the isosceles triangle, and you may be asked, hint, to find that on your test. It's just the opposite. So if I have 2 congruent angles, then the legs, or the 2 sides opposite or across from the angles, are congruent. So if I come over here to the side, I'm going to label an isosceles triangle. So I have 2 sides that are congruent. Remember, those are called my legs. And if I have 2 legs congruent, I also have the angles across from those. Remember, we talked about across from. Those are going to be called our base angles. So those 2 theorems that we just talked about, the first one said if I have legs congruent, then my angles are congruent. And then just the converse, just flipping it around, if my base angles are congruent, then my legs will be congruent. We also actually talked about this angle up here being called our vertex angle. The angle that's included between the 2 legs, we said, or just the other angle. One last thing about those base angles, we kind of created an equation. So if you're asked to find a base angle, or you're given a base angle, you know that you can find a base angle by saying 180, and you're going to subtract your vertex angle from 180, and you're going to divide that number by 2. So make sure that goes in those parentheses in your calculator. You divide it by 2 because, remember, you have 2 angles that are the exact same measure. All right, going back down to finish out our classification of our sides, equilateral just means all 3 sides are congruent. So it may look something like this. And we learned 2 things kind of all the way throughout this section. If it's equilateral, it is also equiangular. so we know that all of the angles are congruent if all the sides are congruent. Also, because it's equilateral, and we know that that makes equiangular, we know all, or each angle, we'll put each because that helps clarify, each angle equals 60 degrees. So over here we can mark an equilateral triangle. We also know it's equiangular, and that's going to equal 60 degrees. All right, we finished out classifying a triangle by its sides. Now we can classify it by its angles. If it is acute, we know that all angles are less than 90 degrees. So all of them have to be less than, not just two, but all of them. If it's obtuse, I only need one angle that is greater than 90 degrees. So only one, remember, can be over 90, and that would be obtuse. If it's right, it's only one angle is 90 degrees. So we can only have one angle equal to 90. And if it's equiangular, like we just said, each angle equals 60 degrees, and that will always be the case. Back up there just a little bit, all angles of a triangle add up to 180 degrees. Remember, that's our triangle sum theorem that we talked about earlier. All right, another concept we talked about is an exterior angle, and I will go ahead and label some parts. I'm going to label A, X, Y, Z. Knowing that the angle A is our exterior angle, and we had an equation to solve for that exterior angle. We said it was A, my exterior angle equals the sum of the two interior angles that it doesn't touch. So notice that it touches Z, or it's adjacent to Z, so I'm just going to add X and Y together, and that would equal A. I also know just a little bit more information. A and Z form a linear pair. Just a side note. And remember, linear pairs are supplementary. They equal 180 degrees. All right, we have played the matching game before. Remember, the matching game is when we talk about corresponding parts. So remember, those corresponding parts are the sides can correspond and also the angles. And this is when order matters. When we are comparing two angles, that is when order matters. So remember, I can say angle X right here. The first one is congruent to angle N. I can also say angle Y is congruent to angle P. And last, I can say angle Z is congruent to angle Q. Again, playing that matching game, the first goes with the first, second with the second, third with the third. Now, that sometimes gets easy, but remember, when I start to match up my sides, if I say XY, I have to put it as congruent to NP. So the first and the second goes with the first and the second. Now, can I say ZY is congruent to PQ? So ZY, third to the second, goes with the second to the third. That would not work. I would have to say ZY is congruent to QP. And then last, I could say that ZX is congruent to QN. So just make sure all of those parts are kind of matching up together. All right, in the last video, we talked a lot about these 5 tools in our toolbox. We're just going to kind of go through a small portion of it. we need 3 congruent statements to prove triangles are congruent. So that might mean 3 sides, that may mean 2 sides in an angle, that may mean 2 angles in a side. It just kind of depends. So when we have triangles, we need triangles congruent to prove corresponding parts. So that may mean my side is congruent to a side. Remember, I have to prove triangles congruent first, or an angle is congruent to an angle. I have to prove triangles congruent first. So make sure that happens. Now, the next part, if I have my proof statement to be a triangle is congruent to a triangle, my reason in that proof, I would put one of the 5 different tools. So that may mean side, 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 angle, side, angle, angle, side. Remember, the side is not between the 2 angles. Angle, side, angle, there is the included side, or HL, that only works with the right angle, that hypotenuse leg. And then the last thing, if you are trying to prove corresponding parts, so maybe I have a side is congruent to a side, so that's when you look up at that prove statement before you even start and say, does it say triangles congruent, or does it say a side or an angle? And remember, if it says the side is congruent to a side or an angle is congruent to an angle, I have to first prove triangles congruent, and then these parts are congruent because of CPCTC. Corresponding parts of congruent triangles are congruent. I hope this information helps, and I hope that you did get your study sheet filled out. If you have any questions, please come see me. Hope you have a good night.